In this demo, we'll be presenting our work on analyzing consistency guarantees in Cassandra distributed key value store. First, we'll show how we can formalize Cassandra as a probabilistic model in MOD. Then, we will describe the quantitative analysis of strong consistency in Cassandra using a model. In the end, we'll compare our results from our formal model and results from our real-world deployment and show that they both indicate similar consistency trends. This diagram illustrates a rewrite rule that models a coordinator forwarding a write request from a client to interested servers. The dashed line represents a local state fragment, where a state containing a coordinator with an incoming write request can transit to a state where a coordinator has forwarded the request to servers 1 and 2 respectively. This is a textual view of the same rewrite rule we saw graphically in the previous diagram. The highlighted text above the arrow corresponds to the previously shown initial state fragment, where a coordinator receives a write request from a client, while the highlighted text below the arrow corresponds to the final state fragment, where a coordinator has generated write requests to all the interested servers. These are our results for the probability of strong consistency in Cassandra using our statistical model. The probability of satisfying strong consistency varies based on the issuing time difference between the given read request and the latest write request. Based on our experiments, we observe that the probability of satisfying strong consistency is very high. Here, we show how to use Pivesta statistical model checking tool to quantify strong consistency in our Cassandra model. Pivesta takes as input a probabilistic MOD model and can verify a property up to a user-specific level of confidence by running Monte Carlo simulations of the model. Therefore, when you invoke the Pivesta tool, it will generate the probability of satisfying the user-specific property. According to the output, our Cassandra model satisfies strong consistency with the probability of 92.7% for reads for quorum consistency level. The whole computation generated 5,220 samples over 54 seconds, obtaining a 99% confidence level. These are our results for probability of strong consistency in Cassandra on a real deployed cluster, which also show that the probability is very high. In general, it's hard to exactly match the experimental configurations from two sides due to the difference in theory and environmental setup between two approaches, but we have tried to build similar environment setup for our experiments. When we compare the results from our formal model and real deployed cluster, we can clearly observe that both the plots follow the same trends. This substantiates our claim that our formal model is correct and therefore can be used for designing new strategies and evaluating them quickly at an early design stage.